Symmetry. A graph is symmetric with respect to the y-axis if for every point xy on the graph, the point negative xy is also on the graph. It's as though there's a mirror on the y-axis. If I put ink to the left of the y-axis and folded the paper in half, we see the symmetry. A graph is symmetric with respect to the x-axis if for every point xy on the graph, the point x negative y is also on the graph. It's as though there was a mirror on the x-axis. If I put ink on the graph just above the x-axis and folded the paper along the x-axis, we would see the symmetry. A graph is symmetric with respect to the origin if for every point xy on the graph, the point negative x negative y is also on the graph. And here, it's as though there's a mirror held up along the line y equals negative x. A function that is symmetric with respect to the origin reflects either from quadrant 1 to quadrant 3, or it reflects from quadrant 2 to quadrant 4. A graph has symmetry about the x-axis if we get an equivalent equation when all the y's are replaced with negative y. A graph has symmetry about the y-axis if we get an equivalent equation when all the x's are replaced with negative x. And a graph has symmetry about the origin if we get an equivalent equation when all the y's are replaced by negative y and all the x's are replaced by negative x. We're asked to determine if the function is symmetric with respect to the x-axis, the y-axis, or the origin. In this case, y equals x squared plus 2. So let's check the x-axis first. So we start with y equals x squared plus 2. We're going to replace x with negative x and see if we get the same equation. Back again. This is symmetric with respect to the x-axis. So if we want to check the y-axis, we replace y with a negative y, and we can't get the same equation there at all. So this is not symmetric with respect to the y-axis. If we want to check if it's symmetric with respect to the origin, we need to replace both y and x with their negatives and see if we can get the same equation, and I'm afraid not. So this is not symmetric with respect to the origin. Notice I have to check all three. I can't just say, well, I checked the x-axis and the y-axis and that means I've checked the origin. I have to check all three. The equation y equals x squared plus 2 is only symmetric with respect to the x-axis. Now we want to talk about even and odd functions. A function is even if f evaluated at negative x equals f of x for all x in the domain of f. This means the graph of an even function is symmetric with respect to the y-axis. A function is odd if f evaluated at negative x is the opposite of f of x for all x in the domain of f. The graph of an odd function is symmetric with respect to the origin. A function may be even, odd, or neither. In this example, we're asked to determine whether the function f of x equals x squared plus 2 is even, odd, or neither. So when I'm determining even or odd, I always begin by plugging in negative x to the function. So is it true that f of negative x, that's negative x squared plus 2, that is equal to x squared plus 2, and that actually equals f of x. F is an even function. Now a function is either even, odd, or neither. It can't be all three, it's only one. In this example, I want to determine whether the function f of x equals x cubed plus 2x is even, odd, or neither. I begin by plugging in negative x instead of x. So I have negative x cubed plus 2 times negative x. So that's going to give me negative x cubed minus 2x. And I notice that actually is negative x cubed plus 2x. So that's the opposite of f of x. F is an odd function. In our final example, we want to determine whether the function f of x equals x squared plus 2x is even, odd, or neither. So I'm going to plug in negative x squared plus 2 times negative x. So that's going to give me x squared minus 2x. Now that certainly does not equal the function I started out with, f of x. So this is not an even function. But it's also not the opposite of f of x. It does not equal the opposite of f of x, because that would be negative x squared minus 2x. This function is neither odd nor even.